Here's an example of finding reference angles for angles in radians. Now that's not written very clearly, so let me make it better. This is 12/5. I don't like that 5. My 5s aren't the best. 12/5 pi. This one down here is 9/7 pi. Okay, so we want to find the reference angle of 12/5 pi. Well, we got to be clear what a reference angle is first off, and a lot of times people aren't clear. A reference angle is the positive angle distance to the nearest x-axis. Okay, so if you're at 12 pi over 5, let's start with that. So 12 pi over 5. Where exactly are you? 12 pi over 5. That's a little tricky. A couple things you could do. You could change that. Remember how to take numbers like 12/5 and change them? You can long divide the bottom into the top, goes in there 2 times, remainder 2, so it's 5, and not 5, it's 2. Try that again, it's 2, 2, and this over this, 2/5 pi. So 12/5 pi is the same as 2 and 2/5 pi. You can double check it. Remember the rule where you multiply the bottom and add the top. 2 times 5 is 10, add 2 is 12/5 pi. So you could do that. Now, why am I doing that? Well, that means it's 2 pi plus another 2/5 of a pi. Okay, why do we care about that? Well, I'm trying to find the quadrant. So to find a reference angle, step 1 is find the quadrant. And then step 2 is find the angle distance to the nearest x-axis. So if this angle 12/5 pi is 2 and 2/5 pi, then it's 2 pi and 2/5 more. So that means here's the unit circle. So that means it's 2 pi, meaning it's all the way around, and 2/5 more. Well, how much is 2/5? Well, 2/5 is almost a half. It's going to be somewhere up about there. That's 2/5 of a pi. So that's 2 pi plus 2 pi, right? I did a whole 2 pi around and then 2/5 more. Now you might wonder, how do you know that's 2/5? Well, this is a half of a pi, right? To here, pi over 2, half a pi. And isn't 2/5 less than half? 2 out of 5, right? If you ate 2/5 of the pie, you ate less than half the pie. So that's why I'm saying it's somewhere right before the half pi. I don't care exactly where, I just have to find the correct quadrant. So it must be in quadrant 1, because it did a whole 2 pi and then 2/5 of a pi more, which is a little less than half a pi. Now, I know some of you aren't going to appreciate that or like that method. So the other option, which you might prefer, the other option is just to change it to degrees. Other option, change to degrees. How do you do that? By plugging in pi. Remember what pi is? It's 180 degrees. Pi radians is 180 degrees. So you take that 180 and you pop it in for pi. So this is 12 times 180 over 5. I'm going to use my calculator. 12 times 180 divided by 5. I'm getting 432 degrees. Now, of course, you want to subtract 360 because that's more than a full rotation. And this leaves us with, 72 degrees. 72 degrees. So, in other words, this angle it's a full 360 plus 72 more to make the whole 432. So it's a full 360 all the way around and then 72 more. See how it's just before 90 degrees? Same spot. We end up in the first quadrant, don't we? Either by the little tricky 2 and 2/5 pi, 2 pi around and 2/5 more, or the 72 degrees after doing 360. Either way, you end up in the first quadrant. Now, what's the reference angle? Here you are, you're standing right here, and it's the reference angle is the positive distance to, remember, the nearest x-axis. What do I mean by nearest? Well, there's two sides to the x-axis. There's the positive x-axis and the negative. If you're standing right here, which side's closer? Barely this side is, isn't it? So from there to there, the distance from there to there is going to be the reference angle. And how far is that? Well, that's just going to be the 72 degrees. But we can't give an angle in degrees. We have to give it in radians. So it's going to be the 2/5 pi, isn't it? It's going to be the 2/5 pi. Because that's how far from here to here is 2/5 pi, because we went around a whole 2 pi and 2/5 pi more. So that reference angle, that distance from here to here, must be 2/5 pi. Do you see that? That's the reference angle. So this first one is 2/5 pi. They make you put in a fraction of pi. You can't put in a decimal or degrees. So it's 2/5 pi. So really, we just took the 12 pi over 5, we changed it to 2 and 2/5 pi, took out the 2 pi and said, well, after a 2 pi, you go 2/5 pi more. That's the reference angle. Let's try the next part. 9/7 pi. 9/7 pi. Well, first step is to find the quadrant. We could just change to degrees. That might be easier if you prefer. Plug in 180, right? Pi is the same as 180. Pi radians is 180. Do that in your calculator. 9 divided by 7 times 180. I'm getting 231.4 blah, blah, blah degrees. So it's basically 231 degrees. Which quadrant's that? Let's go find it. 200, I got to erase all this stuff. 231 degrees. 231. Let me see. That's right, a little past 210, isn't it? So maybe about, or a little past 225, I mean. So maybe about right there. 230. Well, I guess it'd be right between 225 and, here, let me try again. It's kind of right in the middle between these guys, isn't it? And that comes from 0 degrees. So, right there. So we're saying from there to there is our angle. Now it's about, what we say it is? It's about 231. Oh, it's actually closer to the, whatever, good enough. I'm tired of playing with it. That's 231.4 degrees. But really, that's just an approximation because the decimal goes on and on. See the dot, dot, dot. But really, it's 9/7 pi, isn't it? So that's truly 9/7 pi. That's what it really is. Now, that's along this edge, 9/7 pi. But we need the reference angle. What's a reference angle again? It's the positive distance to the nearest. It's the positive distance to the nearest x-axis. So here's the negative x-axis, the positive. This one's obviously, if you're standing right here, this is the nearest right there. So how far is it from here to here? That's going to be our reference angle. It's that distance from the from where we're at to the nearest x-axis. Well, how do you find that out? This spot is 9/7 pi, isn't it? What's this spot here? Pi. Look at the, see on the unit circle? Maybe I erased it. There it is. It's hiding. Pi. Right there. So that means that's pi, and this is 9/7 pi. So our reference angle, so what we're saying is, let me see if I can be super clear on this. So from here to here is 9/7 pi. But from here to there is pi. So the difference between them, this right here, the yellow minus the green, right? It's this reference angle must be 9/7 pi minus pi. The difference between the how far to the nearest x-axis, the yellow minus the green. Okay, so right, that's the yellow minus the green there. All right, so I'll quit playing around with my colors here. So how do we subtract 9/7 pi minus pi? well, you got to get a common denominator. Make this 7/7 pi, right? Because that's just 1 pi, the same as pi. And now you can subtract them and get 2/7 pi. That must be the reference angle. That must be how far between those two. How far to the nearest x-axis? 2/7 pi. 2/7 pi. There we go.